I'm Dr.S.Arulselvi, Associate Professor, Department of ECE, Bharat Institute of Higher Education and Research. I'm going to discuss about the topic Introduction to Communication Engineering. Introduction to Communication. Communication is nothing but exchanging information from one place to another. So, otherwise, it is defined as the process of exchanging information. So, what are the elements needed for a communication system to take place? So, transmitter, communication channel, receiver. The human generated message, what we call it as an information or the signal. So the information generated from the source, it cannot be transmitted as it is over long distances. Therefore, it is given to the transmitter. So the transmitter, it converts the information into suitable form in order to transmit over the communication channel. And then the message is picked up by the receiver. The function of the receiver is to convert the information back to its original form, which is relayed to the another human. Noise is nothing but an unwanted signal that degrades the transmitted information. This is the block diagram of the communication system. Information source, which is used to generate the information. The information may be either sound, picture, speech, data, etc. So this information is first given to the input transducer. The function of the transducer is to convert the information into electrical signal. So this electrical signal is given to the transmitter. The transmitter is nothing but an electronic component which is used to convert the information into suitable form in order to transmit over the communication channel. That is, the information generated from the source, it will be a low frequency one. So it should be converted into a high frequency signal. Therefore, it is impressed upon some high frequency carrier signal. So this process is called modulation, which is done at the transmitter side. So after that, it is given to the channel. So the channel is nothing but the transmission medium. So which is used for transferring the signal from the transmitter to the receiver. There are different types of transmission medium. One is the twisted pair of wires, coaxial cable, fiber optic cable. In the case of wireless communication, the electromagnetic wave acts as the carrier. And then the receiver. So receiver which receives the information from the channel. So it is a set of electronic components. So which is used to demodulate the signal. That is, the function of the receiver is to extract the information from the carrier and it is given to the output transducer. The function of the transducer is to convert the electrical signal back to the original form and which is delivered to the destination. Here, noise is an interference. It is an unwanted signal which interferes with the information during the transmission of the information through the channel. So this shows the electromagnetic spectrum. So the radio frequencies that is occupied by the electromagnetic spectrum. So the radio frequencies ranges between 10 kilohertz to 10 to the power of 16 hertz. Ranges between 10 kilohertz to 10 to the power of 16 hertz. Signals that carry the frequencies of very low frequencies and low frequencies will have the transmission medium of twisted pair of wires, and then the applications of this signal traveling in this frequencies are cable, submarine cable, navigation, and then the signals which travel in the frequencies of medium frequency and high frequencies. The transmission medium used is the coaxial cable. The applications of the signal in the frequencies of medium frequency, high frequency, and very high frequency are the AM broadcasting, amateur radio, mobile radio. And then signals that travel in the ultra high frequencies and super high frequencies, the transmission medium is the waveguide. And the applications of the signal traveling in these frequencies are the mobile communication, transmission of TV, and then radar communication, microwave communication, and satellite communication. And the signals beyond the frequencies of 10 to the power of 14 hertz to 10 to the power of 16 hertz, they are called the infrared rays, visible rays, and ultraviolet rays. So the optical fibers acts as a transmission medium, and the main applications of the signals traveling in these frequencies are the telephone local area networks. modulation. So in the modulation process, two signals are used. One is the modulating signal, other one is the carrier. So the modulating signal is nothing but the baseband signal, which is a low frequency one. So the baseband signal cannot be transmitted over long distances, which is a low frequency one. Therefore, it is impressed upon a high frequency carrier signal. So this is called modulation. In this modulation, some of the parameters of the carrier signal, that is amplitude, frequency, or phase, is varied in accordance with the amplitude variations of the modulating signal. So this modulated signal is then transmitted by the transmitter. So the receiver, he demodulates the received signal, modulated signal. That is, it extracts the message from the carrier and due to which the original information is obtained. So this demodulation is exactly opposite to the modulation. In the process of modulation, the carrier signal, which carries the information from the transmitter to the receiver. What is the need for modulation? So why you are going for modulation? So the information generated from the source, it will be a low frequency one. It cannot be transmitted over long distances. So therefore, it is impressed upon some high frequency carrier signal in order to transmit over the long distance. So that is the need for modulation. So what are the advantages of the modulation? First one, reduction in the height of the antenna. The signal before modulation, that is the information generated from the source, it will be a low frequency one. But the height of the antenna, the size of the antenna is always comparable with the wavelength of the signal. That is comparable with the wavelength of this. That is, it should be lambda by 4 of the, it should be always equal to lambda by 4. So here, if you already know that the frequency and wavelength are inversely proportional to each other. So if the frequency is very low, the wavelength will be more, due to which the height of the antenna is increased. That is the size of the antenna. It is impossible to construct the size of the antenna. So after modulation, the frequency of the signal is increased. So due to which results in the decrease in the wavelength of the signal, due to which the size of the antenna gets reduced. Next, avoids mixing of signals. So due to the modulation, so before modulation, if the signals are transmitted, so they will get interfere with each other. The receiver cannot able to separate them. So after modulation, all the signals, they are modulated by using different base carriers. Therefore, they will be differentiated on the frequency basis. There is no mixing is possible. Since they are differentiated on the frequency basis, there is no mixing is occurs in the, there is no mixing occurs in this. So therefore the modulation avoids the mixing of signals. So next one, increases the range of communication. So the information generated from the source is a low frequency one. The energy of the signal, it depends upon the frequencies. So since the frequency is very low, if it is transmitted over long distances, it will result in the attenuation of the signal. After modulation, the frequency of the signal gets increased. So due to which it can be transmitted over long distances without attenuation. Therefore, the range of communication is increased. Next one, multiplexing is possible. That is, in order to transmit n number of signals through the same channel, multiplexing is used. So multiplexing is possible only due to the modulation. Next one, improves the quality of reception. That is, the receiver should be always capable of correcting and detecting the errors introduced by the channel. So in the case of frequency modulation and pulse code modulation, it provides better noise immunity, which improves the quality of reception. So we are going to discuss about the types of modulation. So various types of modulation, continuous wave modulation and pulse modulation. This continuous wave modulation is further categorized into amplitude modulation and angle modulation. So this angle modulation is further categorized into frequency and phase. So this continuous wave modulation, both the modulating signal and the carrier signal will be a sinusoidal waveform. And here in the amplitude modulation, the amplitude of the carrier is varied according to the message signal. So in the angle modulation, which is categorized into frequency and phase, in the frequency modulation, the frequency of the carrier signal is varied according to the modulating signal amplitude. In the phase modulation, the phase of the carrier is varied according to the modulating signal amplitude. So in the pulse modulation, the message signal, it will be a sinusoidal waveform and the carrier signal will be in the form of pulses. So that is called the pulse modulation, which is categorized into analog modulation and digital modulation. So this analog modulation, the various categories are pulse amplitude modulation, pulse width modulation, and pulse position modulation. In the pulse amplitude modulation, the message signal, it will be a sinusoidal waveform and carrier signal will be in the form of pulses. So the amplitude of the pulses is varied according to the message signal amplitude. The message signal amplitude is at positive peak. The amplitude of the pulse is increased, and if the message signal is at negative amplitude, the amplitude of the pulse get decreased. So increase or decrease in amplitude of the pulses is proportional to the amplitude changes of the message signal. So that is called the pulse amplitude modulation. Next one, pulse width modulation. In the pulse width modulation, the width of the pulse, otherwise the duration of the pulse is varied according to the message signal amplitude. That if the message signal amplitude is a positive peak, the width of the pulse is increased. If the message signal amplitude is at negative peak, the width of the pulse is decreased. So the width of the pulse is proportional to the message signal amplitude. So next comes the pulse position modulation. So pulse position means it refers to the starting time of the pulse. The starting time of the pulse here is proportional to the message signal amplitude. The message signal amplitude is at positive peak. The duration between the duration between the successive pulses, it will be more. And if the message signal amplitude is at negative peak, the duration between the successive pulses, it will be less. So that is called the pulse position modulation. So next one is the digital modulation. In the digital modulation, your information will be in the form of ones and zeros, and your message signal will, your information or the message signal will be in the form of ones and zeros, and a carrier signal will be a sinusoidal waveform. So the various categories of digital modulation or the pulse code modulation, other one is called the delta modulation. So the pulse code modulation is nothing but it is a method of converting analog into digital. So the analog to digital conversion process, it consists of three steps. One is called the sampling, other one is quantization, other one is called the encoding. So in the sampling, your continuous time signal, so in the sampling, the samples of the continuous time signal are obtained at fixed intervals of time. So after sampling, you will get the samples which is fixed in time interval, but its amplitude level will be varying. So the next step is quantization. In the quantization, you will be having some fixed amplitude levels. So all the varying amplitude levels are all the varying amplitude levels will be converted into finite number of amplitude levels, will be rounded off to the nearest fixed amplitude level. That is called quantization. So after sampling and quantization, you will get the samples which is fixed in both amplitude and time interval. So in the encoding process, so this discrete samples, so the samples which is fixed in both amplitude and time interval are converted into ones and zeros. So using this pulse code modulation, a continuous time signal is converted into ones and zeros. That is a digital signal. And the next one is the delta modulation. So in the pulse code modulation, more number of bits are used to represent a sample. More number of bits are used to represent a sample. In order to avoid that, you go for the delta modulation. The delta modulation, it will produce a staircase-like waveform. That is, the present sample value is compared with the previous sample value, and if the difference is positive, the step size is increased, and if the difference is negative, the step size is decreased. Likewise, some staircase-like waveform is produced in the delta modulator. So if the step size is increased, means binary 1 is transmitted. If the step size is decreased, means binary 0 is transmitted. Likewise, it uses only one bit to represent a sample. So in the pulse code modulation, it represents more bits to represent a sample. Therefore, the number of bits to represent a sample is reduced in the delta modulator. So that is the difference between the pulse code modulator and the delta modulator. So we are going to discuss about the analog modulation. So in this modulation, a continuously varying sine wave is used as the carrier wave that modulates the message or the data. In these three parameters can be altered to get the modulation. They are amplitude, frequency and phase. So accordingly, three type of analog modulation are there. One is the amplitude modulation, next one is the frequency modulation, other one is the phase modulation. So this is the different types of analog modulation. This shows the high frequency carrier signal and low frequency information. And so in this amplitude modulator signal, so the amplitude of the carrier is increased or decreased according to the message signal amplitude. If the message signal is at positive peak, the amplitude of the carrier is increased. The message signal is at negative peak, the amplitude of the carrier gets decreased. So the increase or decrease in amplitude of the carrier is proportional to the message signal. So this is called the amplitude modulation. So next comes the frequency and the phase modulation. In the frequency modulation, the frequency means it refers to the number of cycles. Phase means it refers to the angle in which the signal varies. So if frequencies vary directly, indirectly the phase also varies. If the phase is varied directly, indirectly the frequency also varies. So in this, if the message signal is at positive peak, the frequency of the carrier gets increased. If it is at negative peak, the frequency of the carrier gets decreased. So the frequency changes occurs at maximum positive and maximum negative of the message signal amplitude. But the phase change occurs only during the zero crossings of the message signal. If the message signal is at towards the rising edge, the message signal amplitude is towards the rising edge, then the phase of the carrier gets increased. And if the message signal amplitude is towards the trailing edge, at that time the phase of the carrier gets increased. Therefore, the increase or decrease in phase of the carrier is proportional to the message signal amplitude. So that is the difference between the frequency and the phase modulation. That is, the frequency changes occurs at maximum positive and negative. Phase change occurs at zero crossings of the message signal amplitude. So therefore, in the amplitude modulation, the amplitude of the carrier is varied in proportional to the message signal. The other factors like frequency and phase, it remains constant. So the spectrum of the amplitude modulated signal, it consists of lower frequency band, upper frequency band and carrier component. So this type of modulation, it requires greater bandwidth, more power, and filtering is very difficult in this type of modulation. The different types of AM, that is the classification of AM. So the AM signal, we already know that it consists of upper sideband, lower sideband and the carrier signal. So the bandwidth of the AM is the 2 into FM, that is twice that of the modulating signal frequency. So two main resources of the communication system are the transmission power and the bandwidth. So here more power is required for transmission in the case of the AM. So our aim is to always save the transmission power and the bandwidth. If you calculate the efficiency of the AM, it will be very less, that is only 33%, because more power is wasted because of carrier transmission. In order to avoid that, you go for the double sideband suppressed carrier AM. In this, the carrier term is eliminated in order to reduce the transmission power. Now the resultant signal, it will consist of only two sidebands, that is upper sideband and the lower sideband. Therefore, the transmission power required becomes less than the AM, but its bandwidth is equal to that of the AM, that is 2 into FM. The bandwidth remains the same, but the transmission power is reduced when compared to the AM. So in order to save the bandwidth, you go for the other technique, that is the single sideband suppressed carrier AM. So this two sidebands, this upper sideband and the lower sideband, they are symmetrical to each other. Therefore, only one sideband is enough for transmitting and recovering the useful information. Therefore, single sideband filter, SSB filter, is used to suppress any one of the sideband, that is either lower sideband or upper sideband, by generating the double sideband suppressed carrier AM signal. Okay. So now the resultant signal consists of either one of the sidebands, that is either upper sideband or the lower sideband. Now in this case, the bandwidth will be equal to Fm. So the bandwidth is very less compared to the AM signal, the AM with full carrier and also double sideband suppressed carrier AM. And power is also very less when compared to the AM signal and the double sideband suppressed carrier AM. So that is the advantage of SSBSE AM. So the other type of modulation is vestigial sideband modulation. So in order to overcome the disadvantage of single sideband suppressed carrier AM, vestigial sideband amplitude modulation is used in the transmission of TV signals. So in that, the low frequency information will contain useful information. So here, if you suppress one of the sideband completely, it will result in the information loss. To avoid that, a compromise is made between the double sideband and the single sideband suppressed carrier AM, that is called the vestigial sideband modulation. In the vestigial sideband modulation, one sideband is transmitted fully and a portion of other sideband is transmitted. So that is called vestigial. Okay. So this sideband is very useful in the transmission of the TV signals. So next comes the frequency modulation. So the frequency modulation, it varies the frequency of the carrier in proportion to the message or the data signal while maintaining other parameters constant. That is the amplitude. So the advantage of FM over AM is the greater suppression of noise at the expense of bandwidth in FM. So it is used in the applications like radio, radar, telemetry, etc. So the efficiency and bandwidth, it always depends upon the modulation index and the maximum modulating signal frequency. So there are various types of FM. One is called the narrowband FM, other one is called the wideband FM. So the bandwidth of the FM signal, it always depends upon the modulation index value. The modulation index is high, then the bandwidth is large and vice versa. Depending upon the value of modulation index, we may distinguish the two types of FM, that is frequency modulation. One is narrowband FM, in which the modulation index is very small, that is it will be very less than 1. And then other one is called the wideband FM, for which the modulation index is large, in which case the modulation index is greater than 1. So the narrowband FM is also called as the low index FM. So the bandwidth of the narrowband FM is same as that of the amplitude modulation signal, which is twice that of the baseband signal frequency. If the modulation index is large, that is it is greater than 10, it is called the wideband FM. If the bandwidth of the wideband signal is too large, that is it is ideally infinite. So infinite number of bands are available in the case of the wideband FM. So next one is the phase modulation. So the carrier phase is varied in accordance with the data signal. So in this type of modulation, when the phase is changed, it also affects the frequency. So this modulation also comes under the frequency modulation. Next to modulation index. Modulation index, it describes the depth of modulation. If the value of modulation index is less than 1, it is called the under modulation. So in the case of amplitude modulation, the ratio of the modulating signal amplitude to the carrier signal amplitude gives the modulation index. So for a perfect modulation, the value of modulation index, it should be equal to 1, which means the modulation depth should be 100%, so which is called the critical modulation. If the modulation index value is greater than 1, that is 1.5, then such type of modulation is called the over modulation. Noise is nothing but an unwanted signal which interferes with the original message signal and corrupts the parameters of the message signal. So this is alteration in the communication process. It leads to the message signal getting altered. It is most likely to be entered at the channel or the receiver. The effects of noise. So the noise, it always limits the operating range of the systems. It also affects the sensitivity of the receiver. The types of noise. The classification of the noise is done depending upon the type of the source, the effect it shows, or the relation it has with the receiver, etc. There are two main ways in which the noise is produced. One is through some external source, that is The source of noise will be external to the receiving system. The other is created by an internal source. That is, the source of noise will be internal to the receiving system, that is within the receiver section. So there are two categories of noise. One is called the external noise, other one is called the internal noise. External source. That is, this kind of noise is produced by the external sources which may occur in the medium or the channel of communication usually. So this kind of noise, it cannot be completely eliminated. The best way is to avoid the noise from affecting the signal. So the most common examples of kind of external noise are atmospheric noise. So this kind of noise, it occurs due to the irregularities in the atmosphere. That is due to the lightning discharges, thunder, storms, etc. So this lightning, it will produce some electrical discharges. So these electrical discharges, it will travel along with your information, due to which our information gets degraded. Next one is the extraterrestrial noise, such as the solar noise and the cosmic noise. So this solar noise is due to the radiation from the sun, and this cosmic noise is due to the radiation from the stars. So these kind of radiations also travel along with the information, and which degrades the information. And then the third type of noise is the industrial noise. So this kind of noise is due to the industrial effect. That is, the ignition systems of the automobiles, it will produce some electrical discharges, it will produce some sparks. So these electrical pulses, it will travel along with the information, and due to which the information gets degraded. So the next one is the internal source. So internal noise. So the source of this kind of noise is due to the receiving components itself. It is the components present in the receiving system. So the components in the circuits, due to the continuous functioning, it will produce a few types of noise. So this kind of noise is quantifiable. Therefore, a proper receiver design may lower the effect of this internal noise. So most common examples of this type of noise are thermal agitation noise, otherwise it is called as the Johnson noise or the electrical noise. So this kind of noise occurs in the case of the resistors. Next one is the short noise. This kind of noise occurs due to the random movement of the electrons and holes. And then next one is the transit time noise. So transit time means it refers to the time taken by the charge carriers to move the junction. So this transit time effect also, it produces some noise. So this is called the transit time noise. And the other one is the miscellaneous noise. So this is another type of noise which includes the flicker, resistance effect, and mixture generated noise, etc. So the various categories of the electronic communication. So first one is the simplex transmission. So this is the one that travels in only one direction. So if the communication takes place only in one direction, so that is called the simplex transmission. A common example of simplex communication is radio on TV broadcasting stations. So all the radio and TV broadcasting stations are able to transmit. So no reception is there. So only one-way communication is possible. And the next one is the half duplex transmission, which is capable of sending the signal in both the directions, but only in one direction at a time. So some networks, it uses the half duplex transmission. It is required to specify this requirement for all the nodes in the network. So an example for this half duplex communication is walkie-talkie. So in the walkie-talkie, at a particular time, we can able to talk or listen. That is called the half duplex. So the most common way of transmission is the full duplex communication. It allows the signal transmission in both the directions simultaneously. An example is the telephone IP service. So this type of transmission can also be called bidirectional transmission. So this shows the different types of communication. So the transmission mode is categorized into simplex and duplex. So this duplex is further categorized into half duplex and full duplex. So if the communication takes place in only one direction, then it is called the simplex communication. If the communication takes place in both the directions, but not at the same time, that is called the half duplex. And if the communication takes place in both the directions at the same time, this is called the full duplex communication. Next one is the multiplexing. So multiplexing is the process of combining multiple signals into one signal over a shared medium. If analog signals are multiplexed, it is called the analog multiplexing. And if the digital signals are multiplexed, this is called the digital multiplexing. So demultiplexing is the reverse process of multiplexer. It separates the multiplex signal and deliver to the corresponding destination. So this is the block diagram of multiplexing and demultiplexing. So here, due to the multiplexing technique, the n number of signals can be able to transmit through the single channel without any mixing. So that is the technique of multiplexing. So here, n number of signals are there. So n number of signals are given as input to the multiplexer. So the function of the multiplexer is to combine all the inputs, and it is transmitted as a single composite signal through the same channel. So the function of the demultiplexer is to separate the signals, and it is delivered to the corresponding destination. So multiplexing is done at the transmitter side, demultiplexing is done at the receiver side. The process of multiplexing, it divides a communication channel into a several number of logical channels, allotting each one for a different message signal or a data stream to be transferred. The device that does the multiplexing can be called as a mux. The one that reverses the process, which is demultiplexing, is called as the demux. So the various categories of multiplexers, analog and digital. So the various categories of analog multiplexer are frequency division, multiplexing, and then wavelength division multiplexing. So the various categories of time division multiplexing are synchronous TDM and asynchronous TDM. So analog multiplexing. The analog multiplexing technique, it involves the signals which are analog in nature. The analog signals are multiplexed according to their frequency or wavelength. In the frequency division multiplexing, in the analog multiplexing, the most used technique is frequency division multiplexing, otherwise it is called the FDM. So this technique uses various frequencies to combine the streams of data for sending them on a communication medium as a single signal. Example, traditional television transmitter which sends a number of channels through a single cable uses FDM. So this is the concept of frequency division multiplexing. So this signal 1, which is given to the modulator 1, this is modulated using a base carrier FC1. The other one, the signal 2, which is given to the modulator 2, which is modulated using a different base carrier FC2. The other one is the signal 3, which is given to the modulator 3, is modulated using some other base carrier FC3. So due to which all the signals are differentiated on the frequency basis. So since they are differentiated on the frequency basis, there is no possibility of mixing between the signals. Therefore, all the signals can be able to transmit through the same channel without any interference. So here in this, all the signals are given to the linear mixture or adder. So as a single composite signal. So after this, modulation is performed and it is transmitted over the communication channel. So this is the concept of frequency division multiplexing. So next one is the time division multiplexing. So in the time division multiplexing, the time frame is divided into slots. This technique is used to transmit a signal over a single communication channel with allotting one slot for each message. Of all the types of the TDM, one main ones are called the synchronous, other one is the asynchronous time division multiplexing. So this shows the concept of time division multiplexing. So these are the various input 1, 2, 3, etc. to 4. So here each input is divided into n number of samples. So each input here is divided into n number of samples. So at the multiplexer, it consists of a commutator switch. So during the first rotation, it will take the first set of samples from various inputs and it will be transmitted in time slot 1. During the second rotation, it will take the second set of samples and it will be transmitted in time slot 2. During the third rotation, it will take the third set of samples and it will be transmitted in time slot 3. So likewise, all the signals are combined and transmitted on the in a through the same transmission medium but at different time slot. Okay, so this is done at the transmitter side, that is combining all the signals and it is transmitted through the same transmission medium but at different time slot. So this shows a frame, transmitted frame, which shows the starting and the ending of the frame, and here it contains the input. So one frame, the first frame will contain the first set of samples from various inputs, and second frame will contain the second set of samples from various inputs. So at the receiver side, the reverse operation is done, that is called the demultiplexer. Here decommutator switch will be there. So this decommutator switch, it will separate the first set of samples and and it will be delivered to the destination user 1, and this the second the sample from the second input, it will be delivered to the destination user 2. So the function of the demultiplexer is to separate the samples and deliver to the corresponding destination user. So this is the concept of time division multiplexing. So next, bandwidth is a key concept in the many telecommunication applications. In the radio communications, bandwidth is nothing but the frequency range occupied by the modulated carrier signal. So the definition of the bandwidth is nothing but the range of frequencies over the system produces a specified level of performance. That is, the frequency range occupied by a signal is called as the bandwidth. Otherwise, the difference between the high frequency component and low frequency component present in the signal. So this shows the bandwidth is always measured 3 dB below the maximum amplitude level. So the difference between the high frequency component and low frequency component present in this signal gives the bandwidth. Thank you.